Here we have the intersection of a tangent line and a secant line.
Oh, so it's, is it 9x is equal to 12 squared?
No. When you're outside the circle, it's always this piece times the whole thing.
Oh, so 9, and then in parentheses, x plus 9 is equal to 12.
12 squared. It always equals to the tangent line squared. So this becomes 81 plus 9x equals 144. You can solve that one. Okay, now 15, when you have intersecting chords that are inside the circle, that's where you can do what you wanted to do on the last one. In other words, that piece times this piece is equal to this piece times that piece, which is what this equation here says.
Yeah.
And you just solve that.
Oh, yeah, I got that one.
Yeah, that's pretty straightforward. Notice the difference. Here's your two primary differences. Here we have intersecting chords, and it's each piece times the other is equal. Here we have an intersection outside the circle, so it's this piece times the whole length of that secant line times that squared. And then the third case is this one here. So what equation am I going to write for this one?
So 7 times 18 is equal to x, and then in parentheses, 5 plus x.
Yeah, x plus 5. Was just on the, I think the secret of a lot of math is establishing a pattern and always staying with it. So if I'm going to use the theorem says that this piece times the whole thing, so I'm going to write 7 times 18 is equal to this piece, x, times the whole thing, x plus 5. Now, to solve this, let's just make sure you can solve this.
Okay. Oh, yeah. So 7.
This becomes 126.
Okay. Which is equal to 5x plus x squared. And then you have to get it into
Quadratic format.
yeah.
In other words, whenever you have an x squared and an x, you want to get it into quadratic format, which is what?
X squared plus 5x minus 146 is equal to 0.
Okay, now